All right, so we've gotten some conceptual grounding in authentication and authorization. Today we're going to be focused on some actual code implementation for the authentication piece. So enabling functionality for users to be able to sign up for this application, to be able to log into this application, and then at a later date we'll work on the authorization part. So once the user has signed up and thus logged in, or just logged in and has credentials, then what can they actually see within the app? So our objectives for today are to first refactor seed data to store hash passwords rather than plain text passwords, because as we've been talking about, we really want to avoid storing plain text passwords at all costs. From there, we'll move on to implementing a sign-up feature in an Express server, because that's what we're working with here. And then perhaps get to implementing a login feature. In all honesty, I'm guessing that for an hour or so lesson, we'll probably only get to the sign up. But we can maybe tackle a login later this afternoon or at a later date. And then I would like to touch on the authorization piece another time too. When I've done this project, like as a code along in the past, it's typically been a three-parter, like one for sign up, one for login, one for the authorization piece. So we'll see how it goes. We'll see what we can get done, before lunchtime. And yeah, we'll see how it goes. So I've got a bunch of resources for you, a couple NPM packages that we'll be using. We'll be using bcrypt. We'll be using JSON Web Token. I've also linked the authentication slides from yesterday that we were looking at, partially so we can just make sure we've got the flow down and kind of use this slide a little bit as, or these couple slides maybe as some reference for what we're trying to do. Kind of a guideline that we can implement. Yeah, question. What?
Can you record this?
Yeah, it's recording. Okay. Yep, absolutely, absolutely. So, any questions on objectives before we dive in? Cool. So, first of all, I would actually like to step back and just kind of get oriented in this project. So, this is a project that we've used in the past as like a checkpoint, essentially, for authentication stuff. So it's a big one. If we look at the README, we see that there's like a lot of stuff going on here, a lot that you're being asked to do. And you know what, actually, first, let's all make sure we're on the same page with prerequisites. So if you have the project, make sure to run an npm install so that you have all the dependencies that kind of came out of the box with it, which we can check, actually. Let's check them in our package.json. So we've got, it's a pretty simple Express server right now. Body parser, Express, connects, PG, all stuff that we're familiar with using, right? And then the next steps are to actually create the database. So we already have migrations, we already have seeds. Basically, this project is kind of ready to rock from a data perspective. So let's all go ahead and create the database. So create DB secrets. Let's just enter that in on the command line. And I'll tell you what, actually, before we can run the seeds. So let's run connect migrate latest as well. And that will create our tables, create our schema. Good, they ran without issue. And we'll take a quick peek at the migrations. But before we run the seeds, I want to implement this first objective, because the seed data, as you'll see, is not hashing anything right now. And we really don't want to store any unhashed passwords in the database. So let's open up the migrations. In this app, we have users and we have secrets. So the design of this app is basically like, there are a couple users that will already be in the database, myself and Berto. We both have a few secrets. And if we get the functionality right, if you log in as me, you'll be redirected to a secrets page that shows my secrets. If you log in as Berto, you'll be redirected to the same page, but it will show his secrets instead. And if you're not logged in as anyone, I think you just don't see any secrets. Obviously, making new users, they won't have secrets, but that's okay. We can still test that we can properly authenticate new users. So if we look at the migrations now, we see pretty straightforward. Auto-incrementing ID field, email, username, and password. Pretty typical stuff that you would be storing in a basic kind of user table. No different levels of access or anything. Again, we're just working on, if I'm logged in as myself, do I see my stuff, basically. And then if we take a look at the secrets schema, auto-incrementing ID, a string of the secret. So these are things, well, we'll take a look at the seed data. And then our foreign key reference back to the user table as user underscore ID, references on delete cascade. Same type of stuff that you've seen and that you've perhaps implemented for a one-to-many relationship. So one user can have many secrets. A secret belongs to one user. Good so far? Right. So let's take a look at the seed data now. I'm going to close the migrations folder down because we've got a lot of folders here. So if we open up the seeds, if we look at the secrets, like, I think these are Bertos. I hate rugs. I've never seen The Wizard of Oz. I like cows more than llamas. And mine are, I only have fun socks and I was a member of an a cappella band, which are both true. What? What? What do you think? Baritone. This was when I was like 12 or something. I was young. We had a very embarrassing concert in front of the whole school. But that's neither here nor there for right now. This is the days before YouTube and any of that stuff. And phones that could record video. So if we look at the seed data now, we've got our two users, Berto, myself, but these passwords are plain text. So first objective, let's fix that. Let's take care of this so that we can hash our passwords. We've been talking a lot about hashing. Now it's time to actually implement it with some code. So, you know what? Yeah, we'll do this and then we'll take a look at the rest of the app too, because it has a front end in here being served from the Express server, which is probably unfamiliar to you. So let's refactor this seed data to use two hash passwords. We are going to need bcrypt for this. So go ahead and open up this link to bcrypt. I already have it open here. It is an NPM package similar to many other NPM packages. So we've got lots of weekly downloads, so we can be fairly sure that this is a good package. And if we scroll down past the security issues and compatibility and all this stuff, so install via NPM. Hopefully you're pretty familiar and comfortable with this by now. I'm just going to go ahead and copy that. You can also just type it into your terminal. But let's do an NPM install bcrypt, B-C-R-Y-P-T. I see people misspell it a lot. Or maybe it was just one guy in my cohort. He couldn't spell it to save his life. B-C-R-Y-P-T. NPM install that. And while we wait, let's go back over to the docs. And let's scroll down, see if we can figure out how to actually use this thing. So we know we need to hash. We knew there's got to be some sort of methods here. So we've got an async method. We've got a sync method. We got bcrypt.hash. Yeah. Huh. Oh yeah, bcrypt.js. Let's see. Oh, it's got twice the number of downloads.
And it avoids the C++ module that gets compiled, which you may have issues with. You don't have all C++ feature on your laptop.
Oh, okay. All right, cool. Let's npm install that instead. Npm install bcrypt.js. Thanks, Dan. Both packages are accomplishing similar things, ultimately.
Yeah, and the other one is, like, bcrypt is way faster. Bcrypt.js does all these fancy, like, big number, like, computations purely in JavaScript, which JavaScript is ill-suited to count that high. So it can only handle up to 7 passwords, but it'll always work. There's no, if you can run JavaScript, you can run Refactor.js.
Nice. Awesome. Fantastic. So as we look through here, it's clear that there's a few different ways that we can implement this that will probably accomplish very similar things for us. This autogen, a salt, and a hash, if we recall this, the salts are what we're adding to our plain text and then hashing a certain number of times. So it looks like we can kind of accomplish what we want to in just about one line here. So this autogen, a salt, and a hash, we can use this .hash sync method, and then it takes two arguments. You guys can't see that. Let me zoom it in. The password, and then the salt rounds. So that's what we'll use. If we're going to be able to use these methods, though, we need to bring the package in, right? So where should we bring that package in? App.js. Who thinks app.js? Who thinks elsewhere? Or maybe both, even. What do you think?
I'm not sure where it goes.
Okay. All right. Thoughts?
Maybe the routes?
Routes, yes. Yes. Connection, probably don't need that. But if think back to our objectives. If we want to refactor seed data to hash passwords.
So, why would you, what is the goal of the seed data? Why is it good to have a plain text password in there? And how could you, if you want to rehash it? I mean, there's reasons for both. Try to come up with reasons. Do you want the seeds file to have your hash value? Or do you want every other code to hash at the time of running the seeds? You don't want to store it right in the password. So what you want to hash before it goes into seed data? I mean, so that you can in the future add your hash to password to the where it's really accessible for yeah, so I kind of like the whole point of seeds is to give you an accessible data set that you can work off of. So that you know how to work with the cat. You go to seeds and you're like, okay, here's the users, here's the secrets or the leads or the widgets or whatever I've got in there. And you can just see the relationship, see the IDs and make sense of it in text. So if that's kind of one of the use cases, one of the goals of the seeds, you probably don't want to hash them in the file because the whole point is you want to be able to go in and look, oh, here's dumb user Joe password, and then here's Mary password. I just didn't want to be able to look at that, but for the purpose of seeds, seeds aren't real users; they're used generally for testing. Right. So in the pursuit of testing, we're not protecting password. The goal is to make it so you can see it, so that for future developers can go in and test each of these roles because they know what username you tried and what password you tried. The question is then, how do you, where do you put the hash method in your C file? There big migrations.
So close. Migrations are really just the schema itself. So the hashing is more when we're entering actual data. And for this particular app, I mean, this particular app is not going to work if we don't hash the seed passwords because.
Let's look at the data in seeds.
Yeah.
We can do so if you were to import a hash password method here, think of it this way, could you use an array like a .map method to transform your array of users to have a hash password before you do the insert? I'm trying to use very terse descriptions. I want you to think about what a seed file can do.
Can we have our cake and eat it too? Can our seed file still indicate to us what the password is while maintaining hashed password integrity in the database? Who thinks we can have our cake and eat it too? Who thinks we? Nah, man. Hard pass. All right, few on each side. So, but the bottom line is we can, because we can leave. We could obscure these passwords in the seed data. Like we could use environment variables. That would kind of like break the seeds though if anyone else wanted to use the app. But
if you just had a hash password function and just wrapped it around that string, you can have the best of both worlds.
Exactly.
And you'd be able to know that when it executes, it's going to be stored as hash. So then when you go back to log in, you just know that you can go and enter that plain text password and it'll go and be evaluated the same way as if it had been organic.
A real, yeah, like a real, quote unquote, real user logging in. So I think it was Bill, you mentioned like we're going to need it in our routes and we absolutely will need bcrypt in our routes for sure, because we need the functionality where someone signs up and posts a plain text password. We need to be able to handle that in the route and hash it and then store that in the database. But even those seed files and migration files may seem like you just put data in, you don't really touch them that much otherwise. We can also just bring bcrypt into this file and then use its hash, use this line of code basically. But bcrypt here is a reference to the package. So let's go over to the seed file. Actually, let's check our package JSON, make sure we're in there. Bcrypt and bcrypt.js, nice. So we'll use bcrypt.js. So let's go over to seeds and let's do const. Why are you doing that? Const bcrypt equals require bcrypt.js. And I'm sure that they have a line indicating, yeah. So this is like kind of the first line on how to use this in Node is the require. Just like we do with any other package, really. We've mostly been using this with middleware and stuff like that in app.js, but there's nothing saying that we can't use it in other files in our application also. So we'll bring in bcrypt, and then let's scroll down again. Let's just copy this line for right now. And just paste it here like as a reference. So this is what we want to do. If we look at this example, we invoke the bcrypt library, we call the hash sync method, and then it looks like we need to pass it a plain text password and then a salt value. So yeah, salt rounds. So let's do that right here. We can actually just I'm just going to write it out. So we'll do bcrypt dot hash sync wrap. Oh no, not for the username, for the password. So instead of just plain text Iago, which is Berto's dog, we'll do bcrypt. I'm having a hard time spelling it now. Dot hash sync, invoke that. We'll put Iago back in there, and then we'll do salt rounds. And 12, Dan? Yeah. So we're gonna be more secure than 8 here. We'll do 12 salt rounds. And let's just do the same exact thing right here. You can copy paste. Let's just copy paste and replace Iago with Yogi. Yogi. Cool. So now every time our seeds are run, as Dan was saying, like any developer can look at the seed files and know, okay, the password for this user is Iago, the password for this user is Yogi. But the data that will actually go into our database should be a hash password, because this hash sync function will run every time we run the seeds, generate that plain text into an actual hash. Questions so far? Yeah.
Every time it goes up, it like exponentially increases the complexity and the computation. So like slower is better. So if you're just fingerprinting files with the integrity, like my value of like 2, it would be easily practical, but different use cases. So 12 makes it, you need a lot of GPUs to crack that.
Yeah. But yeah, you're right. It's the rounds, it's the number of times it's being put through the algorithm.
And it's interesting to like try different numbers in it. You'll see, you can notice how quick it is when you do 4 versus like 8 versus 12 or 20. You couldn't like 20, you'll see it was several seconds. Is this even working? Oh yeah, okay. There's a real big difference as you go.
Cool. Let's see if it works. So we've run our migrations, we've run our migrations, but we haven't run our seeds. So let's get back to the README. So sweet. Let's see if it works. Connect, seed, whoops, run. And actually, did anyone notice that that took a little bit longer than a typical seed? Like usually it's just like boom, right? Did at least on my computer seem like it took at least a half a second longer than usual.
There's a shell shortcut. If you type the word time before any command, it will tell you the actual seed.
Oh, cool. Connect, seed, run. Or time, connect, seed, run. Y'all don't have to do this if you don't want to. 1.83 seconds. Yeah, that seems like longer than usual for a 2-line seed, or, you know, 2 data seed file.
If you run it with 4 and then like 20, you'll see the numbers. Right?
All right, let's try it.
This is a good thing to like feel that like slowing down hashing. Like imagine if you had to run this against like a ring or a dictionary with all the passwords in the world. If every single one took like 2 seconds, like a billion passwords if they all take a millisecond. Oh, okay. We can work that. There's only 86,400 seconds in a day. You can't get that many numbers through. So yeah, making it 2 seconds or like 8.83 longer, 20 seconds longer.
That's significant. So this is the difference. Y'all don't have to do this, but 12 salt rounds was 1.83 seconds. 4 was 1.07. Let's just try 20 for fun. Many seconds now. Even just for 2 runs of this function. Well, lunchtime, everyone. Let's go.
Right, it's like this is the kind of thing that would stop any attacker looking to send data. On the next one.
Not worth the time, not worth the literal energy and money.
Yeah, it just becomes impossible, at least brute force it.
All right, I'm killing this process. Don't do 20. It's too long.
20 might work with the C++ extension, but still it would take like 5 seconds.
Yeah, cool. In any case, great like demonstration of what's happening with the slow hashing. All right, sweet. I'm gonna run it one more time with 12. Cool. All right, now we have seed files. We can still see the passwords. Any other developers can see the passwords. So you can share your projects, you can open source it. But let's really quickly connect to the database and see if we have hash passwords. So if we do psql, whoops, blow this up a little bit. psql secrets, and then let's just select star from users. Cool. So we have our IDs, emails, usernames, and then our passwords look pretty hashed to me. Cool. Anyone else getting a different result? Awesome. Very nice, very nice. All right, cool. Let me get back to my command line. All right, nice. We've got some seed data. We've got our database set up. Now, let's get a little bit more oriented in this project in general. So, the main thing, let's check our app.js. So, we've got some very familiar stuff in here. It's got express and body parser. We don't have much else going on middleware-wise. And we've got some information here about, like, this is like core stuff essentially, or access control related stuff. And our, express app. And then the key thing here is we've got 2 different route files. We've got auth routes and we've got users routes. So they're being brought in as variables here. They're being set set to be used down here. And that's really the bulk of where we're going to work on the server side. So I'm going to close down the seed files and migrations to keep a little bit organized here. And let's open up those routes. We're going to be focused on the auth routes for right now, because these are where login and sign up happen. So if we go to users, though, you can see our ultimate functionality is that we want to be able to just have like a get all, a get one, and then a get user by ID and get their secrets. So that's kind of where we'll be going with it. If you're not familiar with seeing this like queries dot pattern here, the essence of it is that we've just modularized things a little bit more than executing our actual connects queries within the route file. So if we take a quick look, the queries are coming from /db/queries. Just take a quick look at that. I know some of you implemented stuff like this, like controller type functionality in the pairing projects, but basically we're just storing a bunch of methods here that query the database. And so then when we invoke them in the route file, it's just executing these queries. So just things split up a little bit more than we've done so far. And then we also have our connection file, just allowing us to actually connect to our database. Cool. The other thing that is going to be maybe a little foreign to you is that we have this public folder. So this is what you would call a server-side rendered app. Fully, like everything is contained on the server in this app. It's a front end and a back end, essentially. It's not decoupled. So in public, we have an index HTML. Might be a while since you looked at like raw HTML and not React. But we have basically like an input form for logging into the app and creating an account. And then we have a secrets page that should, once we get full functionality, will only display secrets for whoever's logged in. We're also using jQuery in this app, which you may have no exposure to. Don't worry about it. We're not going to be doing much with the front end code. And a lot of it's set up for us already in scripts. So if we just take a look at this real quick, we've got the key thing here is that we've got a login method or a login function and a sign up function. They're doing some DOM manipulation to grab values of what the user inputs, and then they're making post requests to the relevant URL. So right now the key thing for us is this .then block for each of these, which just captures the response from the server and console logs it. So we can spin up this front end with Light Server. I think there are some instructions to serve the files statically from the server itself, but I'm just going to use Light Server. So if you want to do this as well, if you just CD into the public folder, I already have a tab open for that, galvanized secrets /public, and then run Light Server, and we should see the front end of the app. Cool. So it's very basic. A login with an email and a password, and a sign up with username, email, password. My Chrome extension is remembering my username, email, and password from the last time I did these lessons, which is kind of funny. So this is what we're going to be focused on primarily today. We want to be able to sign up with like a new account. So super basic. If we implement login and sign up properly, we'll handle the user inputs. We'll check them against the database, make sure that they don't already exist, get them in the database, issue a web token, and then like redirect to /secrets, I think, .html. And this is the only other page. So secrets, everyone has secrets. If we had full functionality, we would see, and you're logged in as me or Berto, you would see our secrets down here. Any questions on like the front end and what we're kind of trying to do here? Cool. So if you are going to run the front end, actually, you should run nodemon on the server itself first, because I think that the code requires the server to be running on localhost 3000. So I'm going to go ahead and do that now. Cool, that looks good. Whoops, not NodeMon. Light server. So NodeMon on the server itself, light server on the public folder. Cool, we still have a front end. And let's see, do we have any routes that we could test right now for the back end? Now I'm going to close up public. We'll worry about that later. Let's see. We really just have auth routes and users routes. Let's see if we can just make a basic request to this server and see if we get anything. Localhost 3000 hello /users/1. Okay, cool. Looks like it's working. We're getting some information from Berto. About Berto, he's the first user. We get that nice hash password. And if we switch to 2, you don't have to do this right now. I just want to show you, make sure the data is working. Then we get me, and we get my hash password as well. Cool. Got ourselves fairly oriented now. So let's go back to our objectives. So we refactored seed data to hash the passwords. We still know what the passwords are because they're plain text in the seed file though. So now we want to be able to implement a sign up feature. If we go to the README of the app itself now, if we go down to tasks, you can see there's a lot of tasks to complete to fully complete this project, which is why we're not going to be able to squeeze it all into one lesson here. But let's just focus on the top for right now. So I'm actually going to space this out a little bit. We're just focused on sign up process right now. So we need to validate unique email to prevent duplicate. Well, these are going to be the ultimate steps that we need in our sign up route. We need to validate that the email is unique so we don't get multiple copies of the same user in our database. You may recall this from the slides, right? That's the first thing we need to do, check that the email is not in use. And then we need to encrypt the password, which is hashing it with bcrypt, which is why we need bcrypt in the routes file. And then assuming everything goes well to that point, we can then store the user in the database. Then we'll get to generating a session token through JWTs and responding to the front end with the JWT so it can be stored there. And then we just need to account for errors like email wasn't found. And then, so this is all server. There are indications here of what part of the app you need to work on for which piece. So we're really going to be focused on the server stuff. And we may have time to set the client session, basically store that web token on the front end and redirect. So we'll see how it goes. And one last thing, if we go to the scripts for like app.js, this is, again, what's happening when we submit something. When we try to sign up, let's focus in on this one. This gets triggered over to sign up. This gets triggered when you hit submit. This function fires when you hit submit. So we basically just capture all the user data, username, email, and password, store it as a data variable. You could also store this as like a body variable. This is the equivalent in a fetch request of what you're stringifying in the body. And this is using jQuery's post method. This is the same as like a fetch post. It's just different syntax. So we're just making a post request to a particular URL, localhost 3000/auth/signup, pass it the data object, and then log the response. So the corollary to this function is in our auth routes, we have this router.post for signup. Right now, it doesn't execute any logic. It doesn't do any of the things we need it to, but it does respond with a message, sign up successful. So if we click submit right now, you should see a console log on the front end of sign up successful. Okay, cool. So it looks like everything's wired up right. And we can start to dig in here. Actually, there's a lot going on that I'm throwing at you. Any questions on sort of like the orientation within the app or the front end, the back end, what we're trying to accomplish here? All right, cool. So over to the code. Let's start out by actually writing some pseudocode here. So, and I'm gonna jump back and forth between the README and this file. So sign up process. Let's just copy this over here. We need to validate unique email to prevent duplicates. That's one thing we're gonna need to do. We're also gonna then need to encrypt the user's password. Oops. And upon success, store user in the database, generate session token, respond with token. We're gonna focus on that stuff right now, for right now. Cool. And then actually, let's pull the error condition. That's a reasonably easy thing to account for. We won't worry about the client session just yet. So these are the major things we need to accomplish. I'm going to add another one, and I'm going to say capture user inputs. So these are like, you know, the email. Well, I can just leave them on one line. Email, username, password. Because we're going to need to use each of these, or we're at least going to need to use the email, right? If we're going to validate that it's a unique email, we're going to need to capture whatever email they submitted. So let's do that first. Where are these user inputs coming into us from? The form. And so when the form is submitted and a post hits this route, where, like, how can we pull the email specifically? That's like the main thing we need right now. Super close. Who can help him out? It is part of the request object. One more try. Third time's the charm.
Body.
Yeah, body. Yeah, it's all coming through as the body of the request. So let's do const email equals rec dot body dot email, and let's just go ahead and do const body equals rec dot body, and let's just log both of those. Log email and body. Let's make sure that things are coming through. We'll go over to NodeMon, which is restarted a million times, let's just let's like implement that functionality again. You can type whatever you want in for username, email, and password, but I want to hit submit. I want to see logs now. Okay, sweet. So rec dot only doing the body. Wait. Because I wrapped it in parentheses? Why would that matter? Let's try that one more time. Okay. Here it is. Here it is. So we are seeing a log of the email, matt@matt.com, and then we're seeing a log of the whole request body object, which has email, username, and password. Cool. We seem to be in business. I'm going to get rid of that console log since we know that this is working. And I guess I'll leave the body for now. We may need to use it like that. But, all right. We've captured some valuable user inputs. Now let's validate that this is a unique email to prevent duplicates. So we're going to need to now query the database, right? Let's make sure, does it look like this file is ready to query the database as is? I know that might be a little hard to see. Or you can just look on your computer. Are we ready to make connects queries, essentially? No. Exactly. We didn't require connects. More specifically, even than the connects library, is we need to require that connection file that's coordinating the connects library with the local database, et cetera, et cetera. So just as we've been doing, we have a DB folder, and if we open that up, we have connection file. And this is the file that's actually coordinating the connects library. You can see that the syntax has been condensed into a few lines rather than breaking out each step. So again, different ways to write code. I wanted to make it super explicit when we did this together, but like you can condense some of those steps together if you want. But the bottom line is this is what's exporting connects as a library with our configuration information, which we could check in the connects file. So in development, our client's PG, and we're connecting to this secrets database. So in our routes file, we need to bring that in. Let's make some room up here. Do const connects equals require. And what's the path? We're in routes, so we need to step out of routes, / db / connection. I think that should do the trick. Everyone with me so far? Quick thumbs up. Sweet. All right, now we can query the database. So we need to make sure this email is unique. So we're going to need to use our email variable. And we're going to need to query our users table. Users. So help me write this query. What do we start with? Connects. We invoke that, and what's the table name? Users. Do we need to specify like what we're selecting or anything like that? I don't think we do. We kind of just want to check all the data right now. So let's just, that connects users will do. This will should get us access to all the data in the users table. But what do we specifically want to check now? We want to check email fields. So we have found individual fields by ID before, or individual records by ID before. Now we're going to do it with email. So what's the next line that I need here? What's the next connects method that I need to use? Exactly. So where email as a field, as a string, is the email that is passed in as part of the request. And I think that should do it. So let's do a .then, and let's capture the response as user. That semantically makes sense. Again, you can call this response, you can call this whatever you want. And for right now, let's just console log user. Cool, let's try it out. So basically, if I submit this information, right? This is the sign up form. This is a new username, a new email, a new password. I have no idea what's even typed in here. But this should be something that's not in the database, right? So when we see this console log of user, it should be an empty object, maybe an empty object, probably an empty object in an array. So let's just test it and see if we get a log of nothing, basically, in the server. So we'll hit this submit button again. We go back over to the server, and indeed, we see an empty array, which is good so far because that user is not in the database. That email is not in the database specifically. Sweet. So now if we change the email to, let's check the seed file. I think it's matt.windsor@galvanize.com, or no, let's just check it. Cool, yeah. Let's now, I'm just going to copy and paste this email. So this should find an actual user. Submit, check our logs. Cool. We have a result here. We have an array of one object, and then all of the actual information about that record. So it looks like our query is working properly so far. Any questions on where we're at? Cool. Keep it rolling. So if we're gonna now we need to start implementing some conditional logic, right? Because we want to do one thing if the email is not present. We want to do another if it is. So, and that's sort of our failure, our success and failure. So upon success, store, well, I guess after encrypting, but basically like if the user isn't there, then we want to initiate more queries. We want more logic in general. We want to hash the password. We want to get this new user into the database. If they're not found, we want to respond with an error. So I'm just going to do if user, or you could do if user.length. If you want to be really explicit, you could do user.length equals 0 if you want to account for they're not found. There's a few different ways you could write this. I'm going to do if user.length, or maybe if not user.length. So if this comes, I broke something. If this comes back as an empty array, then there's no length to the array. And in that's actually the condition where we want to start getting this user into the database, right? So we can say this is like initiate hashing and get user into DB. And let's just go ahead and do an else now. And what do we want to do in this else condition? This is sort of like our error. Upon failure, respond with error. So what should I put in this else condition? Alert, we could maybe do alert on the front end, but we're in the back end. So maybe do that also. I'm not sure if we have a page for this condition. I guess we could just, because they're already on the sign up page, so they can stay here. I don't know if functionality has been implemented actually to display an error message or anything, but we can, you're absolutely on the right track. Those are all like valid things. For right now, I think I'm just going to res.json with an error message. I'm not even going to bother with a status code for right now. Certainly would be better to implement a status code for this, but for our purposes, in the interest of saving some time, let's just res.json error and a string like email already registered. Please enter unique email. Something like that. The details of it don't matter so much for our purposes, but we want to respond in some way if this user is already in the database. And let's see if that's working actually, because we are console logging the response on the front end. Whoa. So this should kick that response. That's not what I was looking for. What did we miss here? Let's comment this. Oh, what did we miss? Let's just comment this out. There we go. There we go. We had this response outside of our whole query, which I think was kind of overriding. Sweet. So the user's already there. We get the error message. For right now, you don't have to bother with this. I'm just going to test the other condition. Let's success email. Email is good, man. So if this is, we'll go back to matt@matt.com, and cool. So we're hitting both conditions of our if statement. Excellent. And let's go ahead and move this upon failure, respond with error. I'm just going to note that this is the failure condition. Sweet. So let's get rid of this res.json. That's really not what we want to do, not yet at least. So we need to now initiate hashing and get user into the database. So again, we want to protect these plain text passwords. So first thing we should probably do is hash it. And as Bill mentioned earlier, if we want to hash, we need that bcrypt library within our routes file. So I'm just going to go ahead and jump back to the seed file, copy this line right here, const bcrypt equals require bcrypt, JS. Let's get out of there now. Back to our auth routes, and I'm just going to paste that right under our connects, import, and now we can hash that password. So, and actually, you know what? Let's pull the password right out of rec.body also. So I'm going to do const password equals rec.body.password. That should capture it, just like we got email out of the rec.body. So let's hash it. We'll do our hash sync method. I'm just going right back to the docs for bcrypt. I'll copy this line and paste it right in here. Change that to a const. And let's change this variable name to hashed password, just to be super, super explicit and clear about what's happening here. Call bcrypt, invoke the hash sync method, and we don't want bacon. We don't want anything that's hard-coded in here, actually. We want password, right? We want whatever the user submitted as their password. So call hash sync on password. We'll change that to 12 salt rounds. And let's verify that it's working real quick. Let's log hash password. And I'm going to make sure I don't have any other console logs in this file. Good, I don't. So now if we enter a quote-unquote new user, one of the emails that's not in the database, are we okay here, Nodemon? Yeah, okay, sweet. We should see a server-side log of this hash coming through. We go back to our front end and matt@matt.com. Cool. Submit it. And beautiful, we've got a hash password logging out. And in fact, just for funsies, if we submit it again, you can see we're getting actually a different hash, which is good, right? That's what we expect. Even though it's the same plain text, bcrypt is generating, it's got some similarities, but like the details of it are, they're not the same each time, which is exactly what we want out of bcrypt. Excellent. Questions on where we're at now? Like where the password's coming from? Yeah, it's right up here. So basically just capturing the password that the user submitted as part of the request. So let's maybe switch the order of these because we're using email first. So we pull out the email so we can use it in our initial connects query. We pull out the password so we can use it when we hash. And you know what I'm going to do? I'm going to make another variable called salt rounds equals 12, and I'm going to pass that here. I don't know how you feel about the concept of magic numbers, Dan, but I know Berto is really against magic numbers. Magic numbers are basically a number that you don't have the context for. You don't really know, like what is this 12? There's a number here. How do I know what this is without having to refer to docs for bcrypt, stuff like that? Yeah, so there's I think generally speaking, it's a good practice as a developer to avoid magic numbers. So the way to avoid that in this context is we just create a variable, name it descriptively and semantically. And so now anyone else who's reading our code can say, oh, they're calling this hash sync, which takes a password and a certain number of salt rounds. It makes it clearer what is happening in the code. Some of that, I suppose, is an opinion, but like the more explicit, the better, generally speaking. Even though we have another line in our code, so what? It's a lot easier to read. It's a lot easier to understand what's actually happening. and it's specifically with what the heck is this number 12. So salt rounds. You can call it salt, call it whatever you want, but name it something descriptive if you want to do it this way. Cool. Everything should still be working, so we can get rid of our console log. Now, we're going to need to initiate another, and also we're going to write all this in like one big route function here. Ultimately, it would be best to go back and refactor and maybe tighten the section some of these parts off into their own functions, but we're just going to get it to work right now. So I encourage you to go back and refactor and do some nice named functions to do these things, but for right now, we're just going to spread it all out and get it to work. So we need another query because now we're almost ready to insert a new user into the database, right? However, we need to do something with this hash password before we insert the user. What do we need to do with it? Because if we think about an insert, insert method from connects, we usually just pass it one object, right? Rec.body in most cases. Rec.body right now contains that plain text password. So how can we override it? Yeah, go.
Something like rec.body.password equals hash password.
Bingo. Very nice. Very nice. Yeah, we basically just reassign the value that's being stored within that object. So let's do that on this line here. Do rec.body. Actually, you know what? I'm going to do a new line just to separate our variables from our logic. Rec.body.password equals hash password. Why would that not work? That is a great question and thought. What's the issue we're going to have there?
Because rec.body password is always going to be the plain text password, but your password up there is going to be a different variable. So that you want to change the rec.body password, not variable.
Yeah. Yes. Very nice. And this is the essential difference between primitive types in JavaScript and reference types. So our object's a reference type. The actual value that's being stored in password, as Steve was saying, is a primitive type. Even though we accessed it from an object, it's just a string value. So the password that's being stored in this variable is a separate copy of what's being stored in rec.body.password. So if we change password, the password variable, it's changing like a copy of rec.body.password. It's not changing the original object. Yay. Primitive versus reference. Cool. So basically the password that we pulled out was just sort of a temporary thing to make our code a little cleaner and get us to get towards a hash password.
Writing the rec.body.password like that, you'll see that in nowhere examples where like you have a reusable function. And nowhere is like how express apps were envisioned, how they all work. And we just, it's not like all is like the only place you still see nowhere. I don't know. I think there's some nowhere examples that we learn.
Yeah, I think so.
But I don't know how my value is going there is going into it. But that's how you prevent like subsequent requests from accessing unencrypted password. Like if you had other modules that you were importing that weren't yours, or maybe an analytics thing, you definitely did not want to risk leaking a password to some analytics service. That's how you prevent that. So it's like a very specific use case where like it prevents it from like once you've patched it, it means like no other. It's super important for middleware, but like you just don't use that. There's no other calls, like because there's a res.json or whether it will be in there.
Yeah.
There's no other handler, so the data's going to be disposed of immediately. So
Nice.
it's just you'll see that pattern and wonder like why is this necessary? It's to prevent it from like subsequent middleware attachment.
Nice.
So it's like it's a real edge case even.
Cool. So we're protecting ourselves nicely. We're protecting our users nicely. And I guess then us for being sued. No, it's all selfish in the end. Okay, cool. So, and let's really quickly, to make sure this is working, log rec.body. Because that's ultimately what we're going to move towards inserting into the database. Because that should be now the complete record for the user that we want, minus the ID, because the database will take care of that. So once more, I'm just going to submit this. This is a unique email, or an email that isn't already there. Submit, and awesome. In our server logs, we see now basically the exact object that we want to insert into the database. We got a username, we got an email, and we've got a hashed password. Yes?
Where does the first 6 characters are all the same in each hash?
Yeah.
Is that the salt?
Dan, do you know, is that related to the algorithm? So we have seen, it's been this $2A, $12 at the beginning of each. Here, like I'll just hit it again.
Notice that 12 there? That's no accident.
Oh.
That is literally telling it how many rounds. Because it needs to know that. But the reason you don't have to store it like in a separate database field is because it's like telling you right there. And then like, yeah, $2A, and I think it may be like up to the next dollar or the next dot. There is like a delimiter. If you look at the code.
Yeah, we've got like 3 sections, it looks like. 1, 2, 3, separated by the dots.
Yeah, so like one of those is like your salt, one of those is just like metadata, like the game can tell it like how many rounds and what encryption library it's using. So like that's just used by bcrypt on. Like if you just check the bcrypt source, you'll see it splits on dollar like dots. It's like saving you from having to store multiple values in addition to the password. Concatenates them to a string and then parses them.
Yeah, sweet. Good, really good question. Also, one other quick benefit of not using magic numbers. Now, right now, we're only using this number once. But if we were using this number in other places in the file, then we just have to change one variable value and it would change it everywhere. I just want to point that out. So if we go to 8, let's just see if it changes here. Submit. We check the log. Oh, I didn't save the file. Come on. Cool, yeah. So that's definitely the solve rounds right there. Sweet. All right, we'll change that back to 12, and it looks like everything's working. So we're really in business now. We'll wrap up this piece before lunch, and then I would like to dive more into this after lunch. So because we've made some really good progress, but we've got lots to do still. So now our data is like kind of ready to rock. So let's initiate another connects query. So we'll do connects, users, and what do we want to do now? Actually, let's even check this. Here, let's move this comment up here because this is kind of this next step. Upon success, store user in the database, generate session token, and respond with token. So let's just start with store user in the database. So we'll access the users table, and what's the method that we need to use? The connects method. Don't need a where because we're not actually looking for information now. We want to give some information, like get some information, post some information, if you will, into the database. We'll need a dot then for sure, but we need something in between. How do we get data into the database with connects? Insert. Yes, absolutely. Insert. Dot insert. Insert. And we've gone through all this work to make rec.body exactly what we want to insert, so we can just pass rec.body to our insert method. Let's go ahead and chain a returning star so that we get the whole new record coming back to us. And now we can have a dot then. If we don't have the returning star, we just see like 1 or something like that to indicate that a record has been inserted, I think. We want to be restful. So for restful pattern, we want the whole new record returning to us. So dot then, I'm going to call this new user. So this is the response from the database, assuming everything went well. And now let's go ahead and console log new user. And let's hit this route again. I'm going to clear out my nodemon logs. And we'll hit this one more time. Cool. We are really in business now. So we're getting back an array with one object in it. Has all the information from rec.body, email, username, pass, a hashed password. And now we have ID 3 because that's the next user in the database. We had 2 seed files. Now we have a 3rd user. And do we still? Yeah, we have res.json. So now if we try to sign up again, what should happen? Error. Exactly. We should see an error. We submit, and boom, the server has responded with an error. This is no longer, like this user is already in the database now. So it's no longer unique. Looks like our conditional logic is working just fine. Yeah, we're doing good. We just hit noon, so I'm gonna let you go for lunch. I do want to pick this up either right after lunch or sometime this afternoon, and see if we can maybe finish off the sign up and maybe get the login working as well. Should still allow for plenty of personalized learning time. But before we wrap for lunch, does anyone have questions? We've got a lot of stuff going on. Does anyone have questions? Especially questions about like the concept of what we're doing, because the syntax will come. If you understand the steps that we're trying to move through, then the syntax will come with practice. Going once? Going twice? All right, cool. Thank you very much, and have a great lunch.